in the quadratic function, I didn't say anything about domain. And I always say something about domain. Whenever we graph a function, we have to think about the domain. Well, the reason why we didn't say anything is because we already knew the function, and it's always defined on all real numbers. But here, yes, all polynomial functions are defined on all real numbers. However, I'm anticipating the last section of this chapter that deals with rational functions, which have totally different domain. So we're going to have to put it on the list from now on. We always did. We just didn't do it for quadratic. Number 2, degree. Number 3, something we haven't seen before. So I'm going to put those in red. Max possible number of turns. By a turn, we mean a max or a min. We can no longer talk about vertex. So we call them now max min or turns, not vertex or vertices. Number 4, X-intercepts. And what follows is something we haven't talked about before. And their multiplicities. Multiplicity plural. So X-intercepts and each X-intercept multiplicity. We'll talk about it in a minute. 5, and behavior. Haven't talked about this before. We have, but I haven't really mentioned it that way. 6, max min values with TI-84. We cannot do this by hand. 7, Y-intercept. That's you. Okay? I want to prepare you for number 3, number 4, and number 5. Everything else is pretty straightforward. But 3, 4, and 5 are not, because we haven't talked about them before. So let's talk about number 3. The graph of a linear function. Here's the graph of a linear function. What is the degree of a linear function? 1. How many terms, max or min, does a linear function have? None. Degree minus 1, 0. What a function is this?
Quadratic.
Good. Degree?
2.
How many terms does it have?
1.
Degree minus 1. However, what function is this? X cubed. Degree? Degree minus 1. How many terms does this function have? Don't say anything. I just want to follow my hint. This is x cubed. How many terms, max min, does it have?
2.
One more time. Max min means this. Max min. Let's look at x cubed again.
Infinity to infinity, so it has no maximum.
How many? No terms. What was the degree?
3.
How many did you expect it to have?
15.
But it cannot exceed 2. It doesn't mean that it has to have 2. So this says maximum possible number of turns. It doesn't have to have that number, but it cannot exceed that number. So if the degree is 4, what is the maximum possible number of turns that the function can have? 3. If the degree is 7, what is the maximum possible number of turns that the function can have? But it doesn't have to have 6, but it cannot exceed 6. Is that clear? Good. We're going to have plenty of examples. Okay, so I'm here now with the x-intercepts and their multiplicities. So multiplicities. Odd, not odd function, and even. Even appearances. For example, okay, so let's look at this example for a second. X times x plus 1 squared times x minus 3 to the third equals 0. What is the degree of this polynomial? Don't say anything just yet. What is the degree of this? 1. What is the degree of this? Very good. So 1 and 2. What is the degree of this? Good. 1, 2, and 3. So what is the degree of the entire thing? 6. How many solutions will this equation have? Even if they're all the same, I don't care how many solutions I have to write. Since the degree is 6. It has to have 6. Mandatory, I have to write 6. Very good. So please give me 6 solutions from here.
X equals to 0.
Awesome. How many times?
1.
Once. Done. Say it again. Perfect. Awesome. How many times?
2.
Very good. X equals 3. How many times? Awesome. Very good. How many times does x equals 0 appear as a solution?
1.
Multiplicity 1. How many times does x equals negative 1 appear as a solution? Multiplicity 2. How many times does x equals 3 appear again? Multiplicity 3. It doesn't mean that it crosses 3 times at 3. It doesn't mean that it crosses twice at negative 1. And yes, that one it means that it crosses once at 0. But something else is happening here. This is multiplicity odd or even. Right, it's 1. Right? So it's odd. Is this multiplicity odd or even? Even. Is this multiplicity odd or even? Good. So these two will belong to this category. This one will belong to this category. Why? Because 0 and 3 have multiplicity that is odd, which means 1 and 3. So they belong here. And this one has multiplicity even, which will belong here. Let's see the difference between those two. Any odd multiplicity is a cross of the x-axis. In this case, at 0 will be this. Straight cross. But at 3, look what happens at 3. Exactly what happens to x cubed at 0. This is multiplicity 1, and this is multiplicity 3. This will be multiplicity 5. See the difference between 1, 2, and 3? I mean, I should say 1, 3, and 5. This one is straight. It's running through the x-axis. This one, it takes its time. This one is even slower than this one. Again, it doesn't mean that it has 5 solutions at this point. It only says it has 1, but there are 5. What do you think happens here? Do you remember any function that has 2 solutions the same? What happens when there are 2 solutions? Is it a cross or a turn?
Turn.
All the even multiplicities are turns. So this one is multiplicity 2. This one, it cannot be 5. It's even, right? That's too much. 4. We learn a lot about the function, knowing how many times a x-intercept appears in the equation. And the last thing before we start looking at examples is the end behavior. For end behavior, there are only 2 types. Give me a very simple example of a polynomial odd degree that we know absolutely everything about. Odd degree. The simplest possible function that you can think of odd degree.
X.
Of course. So there are 2 options for a linear function, right? If the leading coefficient is positive, what is the end behavior? Where does it come from?
Comes from left to right.
Negative infinity. And where is it going?
Positive.
If the leading coefficient is positive. What is the other option?
Negative.
Good. It's coming from positive infinity, and it's going to, that's the end behavior. So the odd degree, and all of them will do the same thing. Negative infinity to positive infinity if the leading coefficient is positive. Or positive infinity to negative infinity if the leading coefficient is negative. Can anyone give us an even degree function that we know everything about?
Squared.
When the leading coefficient is,
Positive.
where does it come from?
Positive infinity.
And going back to,
Positive infinity.
when the leading coefficient is negative, coming from and going back to. All even degree functions will follow that. All odd degree functions will follow this. Any odd degree you want will follow that or this. Any even degree you want will follow this for greater than 0 leading coefficient, or will follow this for a leading coefficient that is negative. All of them will have this end behavior. Yes, the first example will take a while because I need to talk a lot. But then the next and the next will take less and less. Good, so let's start with, so these are on page 378. And I would like to start with 53. f of x equals 3x squared minus x cubed, and this is problem 53, and we are asked to graph. Bear with me, we'll have plenty of examples. If it doesn't click the first time, still ask, still stop me, please. Okay, so I will fill in a chart. I will put all the information in one spot, and I will not use 15 pages because it would be very difficult to read. Okay, so I put my list away. I would like the domain, please. Awesome, thank you very much. This is done. I would like the degree. Very good, awesome. I would like the max possible number of turns now. It cannot exceed this number. It doesn't have to have this number of turns. Very good. So this is done, this is done. Yes, please.
Why is it degree 3?
This is degree 2, this is degree 3. It's not arranged in descending order. I have to choose the highest degree, and that will be transferred over the entire polynomial.
Okay. I didn't know if we're going to add them together, get 5, and then, never mind, I got it.
I cannot, they're not like terms.
Okay.
No one can combine 3x squared with x cubed. Good, very good. Now, x-intercepts and their multiplicities. How many x-intercepts and how do I determine the x-intercepts? What do I have to write? To find the x-intercepts, I do what? Say it again. Yes, but what do I have to write? Correct. You know this. You just answered to me 5 minutes ago.
0.
Yes. F of x equals 0. So this is 3x squared minus x cubed equals 0. How many solutions do I have to find, no matter what?
5.
Careful. We're not adding the powers. Yes. If the degree is 3, then we have to find 3. Is that okay? Everyone? Perfect. How do I solve this equation? Remember, I have to clean it up. I have to arrange it in descending order. I have to simplify. I can factor before I simplify, and I put it in the correct order. What do I do first? Now I don't like it for a different reason. Why? Exactly. I will multiply both sides by -1. Very good. So now the equation becomes x cubed minus 3x squared equals 0. Yes, now I'm ready to factor. What am I factoring out? Awesome. Very good. And then what is left in parentheses? Very good. And now you will easily identify 3 solutions for me, please. Very good. That's one solution. I agree. Good. And I need 2 more, please. One times -2 is not 0.
What about if x is 0?
Yes. How many times?
2.
What is the multiplicity of the solution x equals 0? What will that mean for the function? What will the function do at the point 2, 0?
Cross?
Even multiplicity?
It'll turn.
Very good. I am going to make myself a note. What is the multiplicity for x equals 3? What does that mean? What will the function do at the point 3 comma 0?
Cross.
Straight cross. Nothing fancy. Correct. I put these points in my chart. So 0, 0, and I write myself that note. 3, 0, cross. Okay, so this is done. The Y-intercept. How do I determine the Y-intercept for any function? What do I have to do? Right, but I already have it, right? When x is 0, y is 0. So this is done already. I need to think of the end behavior. What degree is this? Odd or even? Odd. So it looks like this for the end behavior, or like this. Which one is it? Only one. Number 1 or number 2? What it depends on? It depends on the leading coefficient. What is the leading coefficient? It's not arranged descending order. That's the catch. -1. The leading coefficient, very careful, the leading coefficient is -1. This is intentional. If we don't rearrange it in descending order, we will not identify it correctly. Good. So if the leading coefficient is negative, am I looking at this or this?
Left or right?
Yes. So what is the end behavior then?
Infinity to negative infinity.
Awesome. That's all I needed to say to here. I'm done. I want to add here number 8, the symmetry, please. So this is done. We have this. So number 8, symmetry. If you remember, f of negative x equals f of x, what type of function will this be? Yes. And f of negative x equals the opposite of f of x. That will be odd. Good. Ready? I want you to follow, please. Say it again. Yeah. It's what we studied in chapter 2. F of negative x equals f of x is even, and f of negative x equals the opposite of f of x is odd. From the symmetry. Okay, I want you to follow my marker. Ready? From positive infinity, the function comes towards the origin where it has to turn. It has to come to a maximum, local maximum, because it will cross at 3 comma 0 and go to negative infinity. One more time. From positive infinity, the function comes to the origin where it must turn, but it has to go to a maximum or local maximum, I don't know how high, because it has to come back and cross the x-axis again, going towards negative infinity. And that's our graph. Ready? This is it. We do not need anything else but this little chart. All the information is here. I only need to follow my chart or the 14 pages in the book. It's up to you. Okay, so this is one point, and here's the other. One more time. It's coming from positive infinity towards the origin, as we discussed, where it turns. it has to come to a maximum because you cannot follow the x-axis. It only has 2 x-intercepts. Well, 3, but 2 in here. Has to come to a maximum and then quickly cross at 3, 0. This is the function f of x equals 3x squared minus x cubed. Of course, I cannot determine this without a graphing calculator. And that is the last item on the list that I did not get the chance to check. So we have to put in the graphing calculator and see what we come up. Yes, please.
So you said that we have to put it in descending order. If we were to like see this and know it was in descending, could we rewrite it first? That way we don't.
From the very beginning.
Yeah.
Perfect.
Okay.
Very good idea. Okay, so here we are. In y equals clear, whatever you had, 3x squared minus x cubed. I'm thinking about the viewing window, and I have the graph. I'm going to say -5, -5, and -5, -5. Maybe the height is higher, I don't know. But -5, 5 with a scale of 1, and -5, 5 with a scale of 1. And graph. As expected, it's coming from positive infinity. It turns at the origin. It has to go to a maximum because it comes back and it crosses at 3, 0.
What did you get again? 5, -5, 5.
Yes, all of them. -5, 5, 1, and -5, 5, 1.
Okay.
How do you like decide what's put in window?
Because I already graphed the function. So I knew that all the action is here, not between -10 and 10 and -10 and 10. So I focused on what I needed. Are we okay?
Yep.
Are we okay? Awesome. So the only thing that I need to determine now is this local maximum. And I'm going to tell the calculator to look for it between 0 and 3. So we go to second and calc. And we want to find a maximum, so click on 4. I wanted the calculator to look between 0, enter, 3, enter, enter again, no guess. And you should give me that maximum, roughly 2, 4.
Can you do it one more time?
Yes. So let's do it again with second and calc. I choose 4 because that's the maximum. Left bound, 0, enter. Right bound, 3, enter. It's asking me for a guess. No, I don't want to guess. You can guess if you want. Press enter again, and you get this. I go back to my chart and put in 2, 4. So I know that this 2, 4 is a relative or local max. What is this?
I got 399.
What is that? What is 0, 0? So second and calc. So we want maximum with 4. 0, enter, 3, enter, enter. 2, 4. Is that okay?
R stand for the right?
Say it again. I'm sorry.
That R that you put up there, does that stand for the right? You put R local max?
Oh, relative or
Oh,
local.
relative.
Yeah, it has 2 different names. We use them interchangeably. Relative or local. It's up to you how you want to call it. Some books call it relative. Some so relative or local. Very good. Any questions? Jason, you feel better about this now?
Yeah, it's much easier doing it on this than it was in the book.
I know. That's why I don't, please read it if it's easier for you, follow any steps you want. I recommend once you fill out the chart, then you know you're done. Okay, please choose a degree, or I will choose a degree. Let's say problem 60. And you will tell me what the degree is. F of x equals negative x squared, parentheses, x plus 2, parentheses, x minus 2. I get my chart going. Domain, please. Of course. Degree, please. Before you say anything, look at each and every factor and analyze what you get. Yes? Yes? Good. What degree is that? 2, 1, 1. 2, 1, 1. 4.
I'm sorry, how do you get that?
X squared times x times x.
Oh, okay.
Copy the base, add the exponents. That will be the first term, right? Is that okay? Max possible number of terms. 3. Degree is even. So are we talking about this or this? Because it's even degree. So I have to think in terms of x squared. Not this or this, because that would be odd degree. So is it up or is it down? It depends on what?
That would be down because you have the negative.
Because the leading coefficient is negative, so it has to be this. Look at the leading coefficient. Negative x squared times x will be negative x to the 4th. So what is the end behavior then? Negative infinity going back to? Very good. X-intercepts. How do I find the x-intercepts? That's the y-intercept. How do we find the x-intercepts? Thank you. Negative x squared, x plus 2, x minus 2 equals 0. Of course, I will multiply and clean it up by negative 1. How many solutions will you give me?
3, 4.
Very good. I have to have 4. Degree 4, 4 solutions. Good. Please dictate. Very good. X equals 0 twice. Multiplicity is?
2.
Which means, what will the function do at 0, 0? The answer is either cross or turn. Turn. Very good. Next solution. Very good. Multiplicity. What will the function do at negative 2, 0? Very good. And x equals 2. Multiplicity. Yes, cross. So now I'm going back to my chart. So I put 0, 0 in the middle. I put negative 2, 0, and 2, 0. For these two, I will write what? Very good. And for 0, 0, I will write turn. Now I stop and look at the chart. Ready? It's coming from negative values. You will cross the x-axis at negative 2, 0. You understand it has to come back, because if it doesn't come back, it cannot turn at the origin, right? And then it has to go up to another maximum because it comes back and crosses at 2, 0 to go to negative infinity. Let's do this one more time. From negative infinity, straight cross at negative 2, 0, but it has to turn. because it comes back at 0, 0 to turn again. And then it has to go to a height, I don't know how high, another turn, because it comes back and crosses at 2, 0, going to negative infinity. Ready? Does it make any sense? Yes.
Okay, thank you.
So I start by plotting the points I have. Negative 2, 0, 0, 0, 2, 0. And now all I care about is my little chart, nothing else. So it's coming from negative infinity, crossing straight at negative 2, 0. It must turn, because otherwise how would it will come back and turn again at 0, 0? Then it goes to a high, I don't know how high, but it has to come back, it has to have a turn, has to come back and cross again. One thing I want to mention about the polynomial functions, they're smooth continuous functions. So they do this, right? If you have to lift the pencil or the marker off the paper, something is wrong. They don't have gaps, jumps, nothing of that kind. So this is the function negative x squared, x plus 2, x minus 2. So let's go to y equals, because we have to determine two relative max. One is a relative min, which I have. What is the relative min of this function? Or the local min of this function that I have and I don't need to determine with the calculator? 0, 0. Yes. So in y equals, clear whatever you have and put in negative x squared, parentheses, x plus 2, parentheses, x minus 2, close the parentheses. Now where is the action? Because I want a specific viewing window. So the action happens negative 5, 5, negative 5, 5, or I would say negative 2, 5, basically. Okay. So negative 5, 5 is okay. I already see it here. Negative 5, 5, okay, that's fine. So I'm just going to click on enter. Any questions?
What was the, go back to, no. I'll go back to your number that you put in there. I'm trying to figure out what did I do wrong. I put it in.
You mean the function?
Yeah, the function.
It's the function you have on paper.
Negative x squared, x plus 2,
In parentheses.
parentheses, x minus, you know what?
2.
I'm gonna try it. Okay.
So second calc,
Right.
we want to find the maximum. And I see that the maximum is between negative 2 and 0. Negative 2, enter, 0,
That was my
enter.
fault. I had not put the subtraction, I put the negative 2.
Okay.
Thanks.
My pleasure. Anytime. So negative 1.4 and 4. And now I see there is another maximum between 0 and 2. So second and calc, another max, 4, between 0, enter, 2, enter. And I don't want to guess. And I get 1.41, comma 4. Is this function symmetric in any way?
Yeah.
Yes. It's what type?
Oh,
It's a what type of function? How is it called?
oh, yeah.
Good with respect to the y-axis, but what is it called? Even function. So I'll make my adjustments. So it's an even function. F of negative x equals f of x. I know I have one more minute. I just want to draw your attention to a problem in your book. And make sure that you look at all problems from the book from 3.1 and 3.2 for Thursday, so we can proceed. Okay, so during a diagnostic evaluation, a 33-year-old woman experienced a panic attack a few minutes after she had been asked to relax her whole body. The graph shows a rapid increase in heart rate during the panic attack. Here it is. So it goes up and then it goes down. So this is a very important application. Just 1 minute, I promise. I'll finish in 1 minute. So it goes up and it goes down and it goes up and goes down. How many turns do you see in this function? Awesome. Okay, anyone? How many turns? 3. What do you mean by 4? I go up, I go down, I go up, I go down. This is not a turn, right? Because it continues to go up. So I go up, I go down, I go up, I go down. How many turns? What do you expect the degree to be? One more than the number of turns, right? When we go backwards, if it's degree 4, it cannot have more than 3 turns. If it has 3 turns, what could the minimum degree be? It could be degree 20, but what is the minimum degree that it can be? Is that clear? Will it have a positive leading coefficient or a negative leading coefficient, assuming we are fitting a 4th degree polynomial?
Positive.
If it's positive, it has to look like x squared. If it's negative, it has to look like negative x squared. So let's do this again. Up, down, up, down. What?
Yeah, it'd be negative. 'Cause I guess
Exactly.
I gotta look at the whole thing.
Yes, exactly. Very good. Okay. So that's what I wanted to finish. So please don't forget, if you do not cover these 2 between now and Thursday, you will feel behind. So please do that. Thank you. If you have questions, please stay. I'll be more than